Section 1.3 is on exact linear relationships, and we're going to be doing some modeling. Modeling is the process where we take real-world data and we find a graph or function that will suit the data. All right, let's look at the first example. In this first example, a basement is flooded with water. We're going to let W be the amount of water in the basement after T hours of pumping. So there are some values of T and W listed in the table. For example, 0 hours after it has been flooded, there is 900 cubic feet of water in the basement. So initially, 900 cubic feet. After 2 hours of pumping, it's been reduced to 700 cubic feet. What we want to do is start by creating a scattergram of the data. Okay, so the amount of water we know is going to depend on how long it's been since we started pumping. So this is going to be our dependent variable, and time is going to be our independent variable. The independent variable always goes along the horizontal axis, so I'll put my label for T here, and my label for W, water, the dependent variable along the vertical axis. Let's go ahead and graph those points. Time looks like we can use a scale of 1 to encounter 1 through 8 as the values. And for the water, we're going to need a scale of 100 to encounter 100 through 900 for those values. Once you have your graph labeled, begin plotting the points. The first point, 0, 900. I'll go ahead and draw each of my points. Once you have all 5 points graphed, your graph should look like this. Alright, let's see what the next step is. Part B, draw a line through the points in the scattergram. So get out your ruler and connect these as straightly as you can with a line. It's important that your line goes all the way through the first point and continues on until it goes off of the graph. Notice that these points are exactly on the line. This is an exact linear relationship. In the next section, we'll be talking about some approximate linear relationships. Alright, a definition. If the points in the scattergram form a straight line, then the two quantities from the real-world situation are said to be linearly related. The mathematical description or scattergram is called the linear model, or sometimes just the model. Alright, in example 1, we're going to continue here. Using the linear model, we're going to estimate the amount of the water in the basement after 3 hours of pumping. So I'm going to flip back to the other screen and estimate the amount of water after 3 hours of pumping. So 3 hours of pumping is going to correspond with what looks like 600 cubic feet of water. So the answer to part C right here is going to be 600 cubic feet. In part D, use the linear model to predict when there is 200 cubic feet of water in the basement. So now we're looking at the y-axis, looking for 200 feet of water, and looking for a time that's going to correspond with it. So the time that's going to correspond with it appears to be 7 hours. Another definition. An input is an appropriate value of the independent variable that leads to at least one output, which is an appropriate value for the dependent variable. Let's continue example 1. Is 100 an appropriate input value? So remember that the input values, the independent variable was time, and 100 is not going to be an appropriate value. Why not? Let's go back and look at our graph. Although I could continue this time axis out all the way until we got to 100, it's not going to make sense because I can see that the amount of water has already reached 0 at 9 hours. It will no longer make sense. This line does continue on, but it's no longer going to make sense for time past 10. So a time of 100 will not make any sense. So it's not an appropriate input value. 100 is too large to be an appropriate time value. Part F, what values are appropriate for the output? All right, so the output, let's go back and look at that graph again. The output values are these values for the amount of water. It's appropriate to have any value between 100 and 900. Appropriate to have 0 as well. It's appropriate to have anything between 0 and 900. What about this 1,000 I've labeled? It's not going to be possible to have 1,000 cubic feet of water in the basement because it started initially with only 900. So the appropriate values are going to be the values between 0 and 900. It's also not appropriate for the water level to go beyond 0. We can't have a negative amount of water. So the appropriate values are numbers between 0 and 900. Alright, example 2. Consider the following scattergrams. For each, determine whether there is a linear model that would describe the situation well. If there's going to be a linear model, it's going to mean that we can create a line that goes through the data. So if you look at the first set, in the first set right here, if you try to draw a line through the data, you'll see that a line will go right through all of the points. If you've got a ruler, you can probably line up a little bit better than I could with my mouse here. So for the first one, a linear model definitely does fit the data well. If I consider the second graph and imagined drawing a line through the points, there's no line I'd be able to draw that's going to be able to come close to all of them. So that's going to be a no. And for our last one right here, if I draw a line, it is possible to get this line close to the majority of the data points. I can draw it so there are some above and some below. It is close to all of them. So this is going to be another yes case. I can make a linear model that will describe them well. It's not an exact linear model. This is going to get us on to the topic. We're going to have in the next section an approximate linear model, something that comes close to but does not touch all of the data points. Definition. The x-intercept of a line is the point where the line crosses the x-axis. The y-coordinate of the x-intercept is 0. Second definition. The y-intercept of a line is the point where the line crosses the y-axis. The x-coordinate of the y-intercept is 0. Notice that the opposite value. If there's an x-intercept, it's y that's 0. If it's a y-intercept, it's x that's 0. Alright, let's look back at that first example. Find the w-intercept of the water model. What does that mean in this situation? So if I'm looking for a w-intercept, remember the two variables in this example were w and t. A w-intercept is going to have t equals 0. At the same time, let's go ahead and look for the t-intercept. The t-intercept is going to have w equals 0. Let's look back to that graph. So this point right here is going to have a t value of 0. So that's going to mean that our w-intercept is 900. And this point down here is going to have w equals 0. That's where our w values have reached 0. So that's going to be our t-intercept. The w-intercept is 900. That means that initially there were 900 cubic feet of water in the basement. The t-intercept is 9. That means when the water level reached 0, it had taken 9 hours, or it takes 9 hours to empty the basement. Alright, example 3. Find the x-intercept of the line, then the y-intercept of the line. So the x-intercept, remember, is where y is 0. It's the place where the line crosses the x-axis. So it crosses the x-axis at x equals 2. Another way of writing that x-intercept is the ordered pair 2, 0. Find the y-intercept. The y-intercept is the place where the line crosses the y-axis, where x is 0. So it's going to be where y is -1. Another way of writing that is the ordered pair 0, -1. Find y when x is 6. When x is 6, y is 2. And find x when y is -4. So make sure you don't look where x is -4. Look for where y is -4 and x is -6. Example 4. Let V be the value in thousands of dollars of a car when it's T years old. We've got some data listed in this table. So we know that the value of the car is going to depend on how old it is. So my dependent and my independent variable. So we're going to draw our scattergram and our linear model. We know that the dependent variable will be along the vertical axis, and the independent value will be along the horizontal axis. So let's go ahead and plot all of these points. A labeling system for the independent axis looks like 1 through 10 will work just fine for all of these values. And for the independent axis, it looks like to be able to get all the way up to 20, I should count by 2's. Alright, so once we have our labels completed, we'll go ahead and plot the ordered pairs. So once you get all 5 ordered pairs plotted, we're ready to draw the linear model. And it looks like these will be a perfect line. So let's go ahead and connect them. Again, a ruler is going to be really helpful here. And you want to make sure that your line is long enough. My first line I drew wasn't quite long enough, so I had to extend it. I want it to be long enough so that it crosses both axes. It's going to be able to show me where the 2 intercepts are. Alright, I have some questions about this line. Estimate the value of the car when it is 5 years old. So when the car is 5 years old, we're going to look at its age, T. 5 years old is going to correspond with this value right here, which seems to be about 9. So the value is going to be $9,000. In part C, we want to estimate the age of the car when it is worth $15,000. So I'm looking for $15,000 on the axis and figuring out what year that is. So that corresponds to 3 years. So the car is 3 years old. Part D, what is the v-intercept? Okay, the v-intercept is the place where this graph crosses the v-axis. So it looks like about 23. So we can say V is 23, or a better way of writing that is the ordered pair 0, 23. We want to write it as 0, 23 because when I talk about what does it mean, I need to explain both the 0 and the 23. So the 0 is going to mean 0 times since the car was bought, so the car is brand new, and V is the value. An explanation wouldn't be complete without both of these parts. 23,000 and brand new, describing both the 0 and the 23 in the intercept. Part E, what is the t-intercept of the model? Let's go back up and look. The t-intercept of the model, the place where it crosses the t-axis, appears to be 8. So again, I can either write t equals 8, which is incomplete. What I really should write is the ordered pair 8, 0. When I do the what does it mean, I need to explain both the 8 and the 0. So the 8 is years since the car was bought, and this is the effective value. So the effective value of the car is $0 after 8 years. Another way of saying this is the car isn't worth anything after 8 years.